Hello, let's talk about the reactions of bases with the various substances. Here we talk about how the various bases, the soluble and the non-soluble ones, react with various substances or compounds. So let's see. We'll see the characteristic reactions of the bases. Here as well, we get to see the reactions between these bases with the various compounds. So the first characteristic is the dissolution in water. Most bases are insoluble in water, so some of them are soluble. The soluble bases are known as alkalis, as in the first video we talked about that. Now the common alkalis are the sodium hydroxide, calcium hydroxide, potassium hydroxide, and the ammonium hydroxide or ammonia solution. All alkaline solutions contain hydroxide ions. So alkaline solution is the type of alkaline is the type of base that contains the hydroxide ions. Examples: acids alkali can be classified as like acids. These alkalis can also be classified as strong or weak. Now the ammonia solution is the weak base because it ionizes just partial. So as we saw in the acids that they are strong, they're weak. Uh, the strong acids are the one that ionizes completely, while the weak ones ionize partially. So the same goes to the alkalis. The strong ones are the ones that ionize completely, while the weak ones ionize partially. So example, ammonia solution, this is the weak base which ionizes just partially. Now the rest of other bases are strong bases because they ionize fully into ions in the solution. So that's how we can see that there is some kind of this characteristic that is dissolution in water, that these alkalis dissolve in water. Let's move to the other characteristic, the reaction with acids. As we saw before when talking about the reaction of acids with the other compounds, we said that the acids react with the base to produce salt and water. So also here we can see this character that the reaction with acids, that these bases react with acids to produce salt and water. So this is all other of the characteristic reaction of the base. Moving on, the third one is the reaction with the ammonium compounds. Now the ammonium ions react with base to form ammonia gas. So ammonia gas is liberated when the ammonium is reacted with the base, and it is forming this ammonia gas. So this is the other of the characteristic reaction of the base with the other compound, which is the ammonium compound. Moving on, the other one is the reaction with the aqueous salts of metals. The aqueous solutions of alkalis will precipitate the insoluble hydroxides of other metals from the solution of metal salts. Now only this ammonia, uh, potassium hydroxide and the sodium hydroxide are soluble enough in water, while all the other hydroxides are insoluble and they can be precipitated from aqueous solution by these three alkalis. So we can get example when maybe sodium hydroxide solution is added to copper 2 sulfate solution, a pair blue precipitate of copper hydroxide is formed. As we can see in the reaction that the copper sulfate reacts with this sodium hydroxide, it gives this copper hydroxide and the sodium sulfate. The other example is that the reaction between the potassium hydroxide and the iron 3 chloride, which precipitates the iron 2 hydroxide. As you can see the reaction, the iron chloride plus the potassium hydroxide get iron 3 hydroxide plus potassium chloride. So these are just the few the examples of the reaction of these hydroxides, which are the base reacting with the aqueous source of metals. Moving on, let's see the reaction with the chloride. The bases react with the chloride. So the chloride reacts with the excess of cold dilute caustic alkalis to form hypochlorites. That's their formula is NaLlClO or KClO. So in the reaction, as you can see, the sodium hydroxide plus chlorine, you get sodium chloride plus that hypochlorite, then plus water. Then also there is chlorine gas that is liberated there. The other one is that the potassium hydroxide plus chlorine gas, you get potassium chloride plus the potassium hypochlorite plus water. So the main two components are liberated. That one is the chloride of a metal and this hypochlorite. And the last part is the water. So you get these compounds after the reaction. So if excess chloride is bubbled through hot concentrated solution of caustic alkalis, the chlorates are formed. So example, sodium hydroxide plus chlorine gas, you get sodium chloride plus these chlorates, sodium chlorate and plus water. And the other one is this potassium hydroxide plus chlorine gas, you get potassium chloride plus potassium chlorate. So these are just of the few of the examples of the reaction of the base with the chlorine gas. Let's see the application of acid-base neutralization in everyday life. Neutralization reaction, as we said before, that the reaction of acid and base that produce salt and water. So the following are just of the few of applications. The first one is that it helps in the digestion and the pain relief, as when you eat, there's the production of this hydrochloric acid in the stomach. Now the production in excess leads to the digestion. So also there is also pain in some way when there is in excess of this acid. So to ease the pain, we take the antacid treatment, as the antacids are a broad group of compounds with no toxic effects on the body. So they are used to neutralize the effects of this acid digestion. Also, some of these antacids, such as the milk of magnesium, that is insoluble magnesium hydroxide, help to neutralize and hence counteract the excess acid in the stomach. So this treatment therefore prevents indigestions and the pains. So the neutralization reaction equation is as follows: that the magnesium hydroxide plus that when it reacts with this acid, maybe hydrochloric acid, you produce magnesium chloride plus water. Moving on, in the second application, that in the scaling materials, lime scaling, that is the calcium carbonate is formed inside these boilers, kettles, and water heaters when hard water is boiled. Now, the lime scale can be removed by the treatment with an acid that is strong enough to react with this calcium carbonate, but not strong enough to damage the metal. So vinegar can be used in the descaling these kettles. Commercial descalers use other acid solutions such as the methanoic acid. So these are used in descaling materials in order to make the materials clean and useful in more activities. Moving on, the third application, that prevention of tooth decay. To prevent tooth decay, many types of toothpaste containing basic substances to neutralize the acids produced by bacteria in your mouth. As you've seen that there are bacteria in our mouth when after eating maybe after some time, there are these bacteria that decompose the remaining food materials in our teeth. So on our teeth, so these bacteria can lead to the production of some kind of substance that could be acidic. So the toothpaste are made in a way that they are basically used to neutralize the acids that can be produced when these bacteria are decomposing the food substances in our mouth. The other application is in soil treatment. Chemicals can be added to soil to adjust its pH. Um, often, if the soil is too acidic, it is usually treated by liming. So in this context, liming means addition of this quicklime, that is calcium oxide, second lime, that is the calcium hydroxide. Quicklime is the calcium oxide, where the second lime is the calcium hydroxide, or powdered chalk or limestone has calcium carbonate to an acidic soil. So these compounds have the effect of neutralizing the acidity of the soil. So it helps to neutralize the soil to be useful for the agricultural activities. The other one is that if the soil is too alkaline, acids such as the sulfuric acid, nitric acid, or hydrochloric acid may be added to the soil to neutralize the excessive alkalinity. So, however, these compounds are very expensive and hence uneconomically to apply on a large scale basis. So these are just a few cases when the soil is too alkaline, there will be use of these acids such as the sulfuric, nitric, or hydrochloric acids to neutralize the alkalinity. The other application is the insect stings treatment. The bee sting, which is acidic in nature, may be neutralized by rubbing on a calamine solution which contains zinc carbonate or baking soda, which is the sodium hydrogen carbonate. Now, these compounds are basic in nature, and so have the effect on neutralizing the acid in the sting. Also, as the wasp stings are alkaline in nature and they can be neutralized by vinegar, which contains ethanoic acid. So, anti and nettle stings also contain methanoic acid. These may also be neutralized by rubbing an extract squeezed from crushed onion leaves, which contain the basic compounds on the affected skin. So the acid in the skin can also be neutralized by applying weak alkali such as ammonium solution, ash extract, baking soda, and the others. And the last application that in the factory waste treatments, whereas the liquid waste from the factories may contain these acids. So if it reaches the river, lakes, and the ocean, the acid will kill fish and other aquatic life. So it can be prevented by adding second lime, that is calcium hydroxide, to the waste to neutralize the acid before being dumped into the water bodies. So that's all for this video. Thank you for listening. I hope it's clear, and see you in the other videos.